Measures of central tendency from frequency tables. On top here we can see what is called a frequency table. We have these days of the week and it's counted how many customers came on those days. This is called a frequency count. Alright, we're going to take some notes. Please use the notes page that has been provided to you. The first piece of data or set of data we're going to work with is discrete data. It shows the number of sweets in 24 packets. So one packet had 22 sweets in it, another had 23, and so on. Here's a frequency table for that data. So this is the data set here. As you can see, all these values are some number between 1 and 24. So all the possibilities are 20 to 24. And this is a count. So we have 20 occurring twice. You can see 20 is here and here. 21 occurs 3 times in this list. 22 occurs. So if I count the 22s, the easiest way to count is to just stroke them off as you count. And 22 is 13. 23 appears 4 times, and 24 appears twice. So I've completed the frequency table. So now in this frequency table, if you add all these numbers up, you'll know how much total data there is. So all these should add up to 24 because we have 24 pieces of data. Let's find the mode. The mode is the most frequently occurring one. Well, from the data set, it's easy to see 22. But if you didn't have the data set and you just had the table, you would look at the frequency number. So this tells us that 22 occurs 13 times. So obviously that's the most frequently occurring one. And that would be our mode. So 22. Median. To find the median, we have to know what the middle value is. Don't forget, we always are going to use the little formula n plus 1 over 2 to find the middle value. There are 24 pieces of data, so we do 24 plus 1 divided by 2. That's 25 divided by 2, which is 12.5. So at position 12.5, we have the median value. Well, these ones are not sorted, so we can't just count 12.5 into that list. And also, we don't need to write them in order. We can just look at the frequency table because these are already in order. So if you look at this, we have 20 occurring twice. And then when we go down, we have 3 21s. So now the total is 5. And then if you go to 22, the total of all those is 5 plus 13, which is 18. So if we go all the way to the last 22, we have 18 data points already, but we're looking for position 12.5. So position 12.5 must occur somewhere in there because we had 2 pieces of data, 3 more, and then 13 more. So somewhere in there is position 12.5, and that is 22. So the median is 22. So again, if you wrote this list in order, you would have 2 20s, then 3 21s, and then a bunch of 22s, 13 of them, and the median would be 22. The mean, right, this is to find the mean, we need to add all the values and divide by how many we have, right? So you could add all these from the list, but easier than that, use the table. We know 20 occurs twice, so we're going to say 20 times 2 plus 21 times 3, because there's 3 21s, and then plus, I did dot, so I didn't have to write it all, but it would be 22 times 13 plus 23 times 4 plus 24 times 2. So you do all those, add all those values up, and then you divide by 24 because there's 24 values in total. So that'll be our mean or our average. Please calculate that. All right, hopefully you got an average of 22.04. Now let's look at the second one. This is grouped discrete data. So again, this is discrete data as well, because look at this, it's the ages of people at an outdoor concert. Ages can just be whole numbers, so that's discrete data. It's like a counting number. And let's see, this is called grouped discrete data because we're going to take these values, since there's such a big range of values, like the lowest age is 1 and the highest age is, I don't even know, I don't see it here, maybe 29 could be it. Anyway, there's a big range of values. So if we made a table with each of those values appearing here, like 1, 2, 3, 4, all of them in order, we have a really long table. So to avoid that, we group values. So instead of saying 1, 2 separately, 3 separately, we say let's put 1 to 5 here, and then 6 to 10 here, and 11 to 15 here. That way you make a smaller table. This is called a grouped discrete data table, or grouped frequency table. Notice these signs here are very important. This means greater than or equal to. So that means it can be 1 or greater than 1. And then it says less than or equal to 5. So it can be 5 or numbers less than 5. So what this basically means is that this is for the values 1, 2, 3, 4, and 5, including 1 and 5 because of the equal sign there. So how many times do the numbers 1, 2, 3, 4, and 5 occur? Well, here's 1, here's 2, here's 1 again, there's 4, and there's a 3. So if you count all the numbers between 1 and 5, including 1 and 5, there's 5 of them. This frequency is 5. Then looking for numbers between 6 and 10, including 6 and 10. So if you looked for all those numbers there, it actually happens to be that there's 11 of those. Now we're going to look at numbers from 11 to 15. So in here, any numbers that are 11, 12, 13, 14, or 15, if you count those up, it's 15. There's a lot of those. And then numbers 16 to 20, there's 10 of those. Now let's make sure we write this correctly. Again, it's greater than or equal to for both of these. And it always starts at the next number. So if this had 15, then this is 16. So this was 20, so now this one's going to be 21. So it's 21 less than x less than 25. We're looking for numbers from 21 to 25. You count all those numbers in here. Let's see. Well, you know what? I'll let you do that one. See if you can do this count. Find what numbers between 21 and 25. How many of them are in here? Hopefully you found that to be 6. And then finally, our last category, or this is actually called a class. These intervals are called classes. It's 26 to 30. So now count to 26 to 30. And if you count those values, it's actually 3. Now let's find the mode. When we have groups data, like these classes here, it's no longer called the mode, it's called the modal class, because it basically, the mode is going to be the category here that appears most often. So here we have a frequency of 15. So 15 means that this values in this class occur 15 times. So any numbers between 11 and 15 occur 15 times. But we don't know which number exactly is the mode. We just know that this group of numbers appears 15 times. So our modal class is that group of numbers, 11 to 15. Then the class containing the median. So we're going to look at which of these categories here contains the median. Again, to find the median, we do n plus 1 divided by 2. Here we have 50 pieces of data. So 50 plus 1 divided by 2. That's 51 divided by 2, which is 25.5. So position 25.5. Again, we cannot go in order like this to find the position because these are all out of order. So we go to our table. We know that values 1 to 5, there's 5 of them. And then as we go up in the list, then there's 11 of these. So now the total is 16. And then you get to this group of numbers, and there's 15 more. So the total now is 5, 11, and 15, which makes 31. That means by the time you get to the number 15, you have 31 pieces of data. But we're only looking for position 25.5. So that means 25.5 must have occurred somewhere in here because we had 5, 16 pieces of data, and then we went all the way up to 31. So in this class is where we have our median, somewhere in there, somewhere between 11 and 15. So that's our class which contains the median. So if you reordered these at position 25.5 would be some number between 11 and 15. Now the estimated mean, we can't calculate the actual mean. It has to be just an estimate. And the reason it's an estimate is because when we're using the table, let's actually in this case, you could add all these numbers up and divide by 50 and get the mean. But let's say we didn't have this list and all we were using is a table. In the table, we don't know exactly what values we have. For example, here we know we have 5 numbers between 1 and 5, but we don't know if those are all 1s or all 2s or maybe some 2s and some 3s or some 4s. We don't know. We just know there's 5 of them. So we're going to take the way to do this with this kind of list is to take the middle value, what's directly between 1 and 5. That number is actually 3. So we're going to say that 3 occurs 5 times. Even though it's not really 3, there's a 1, there's a 1, there's a 3. Those numbers aren't all 3, but 3 is the middle number, so we're just going to kind of estimate and say, well, we're going to say it's 3, and 3 occurs 5 times. And then we take the middle number here. The middle number here is 8. So even though these numbers can be anything between 6 and 10, we're going to say all of them are 8, and it occurs 11 times. So 8 times 11. And you keep going the same way. In the last one here, the middle number is 28. So we're going to say 28 occurs 3 times, even though it can be any number between 26 and 30. So that's why this is an estimate of the mean. We're going to do all that, divide by 50 pieces of data, and let's see what you get for the mean. Try that one. All right, hopefully you got 14 if you calculated that correctly. Okay, now we have grouped continuous data. This is like grouped discrete data. It's the table set up the same way, except for this data itself is continuous, not discrete. In this case, it's the time somebody spent talking on the phone in 30 different phone calls. So time can be measured, therefore it's continuous. It can be measured to any degree of accuracy, any decimal place. So first of all, to set up the table, this is a little bit different than the grouped discrete. In grouped discrete, when one class ended in a number, the next class began with the next number higher. So if this was discrete data, this would have been a 5 and then a 6. But since this is continuous, continuous data can be any number. So you don't have to go from 5 to 6 because you want this to end at 5 and this one to begin at 5 because that way you're not skipping any possible values. So this 0 less than t less than 5, this is less than or equal to. That means that in this class we include 0 and then we go all the way to 5, but there's no equal here, so we don't include 5. So we go all the way to 5, just under 5, so like 4.9 would be included, but not 5. Then you jump here. So if you had 5 here somewhere, I don't know if there's a 5, but if one of the data values was 5, it would not go in here, it would go in here, because this includes 5 right here. And then this goes all the way to 10, but does not include 10, there's no equal. So it's only up to 9.9. So if you had a value of 10 in here somewhere, it would go in here, not in here. I noticed there's a 15 here. I think I saw 15. 15.0. So would 15 go in here or in here? Well, 15 would be counted as part of this group because this has the equal sign here. This one is from 10 to 15, but just under 15 because it's less than 15. All right, anyway, so let's count all in this data set, find all the numbers that are from 10 to 15, but not including 15. And that number should be 3. And now we're looking for 15 to 20, but not including 20. And that number should be 4. Then 20 to 25, but not including 25. If you count that, we have 2 pieces of data like that. The next one here should be 25 to 30, including 25, but not including 30, so just under 30. If you count that data here, there's 2 pieces of data. And then continuing on, 30 to 35, 1, and 35 to 40, 1. Now we're going to look for the modal class. Again, one of these classes or categories here, groupings, occurs the most. So which one? Looking at all these, well, this one occurs the most, 10 times. So some number between 0 and 5. Phone calls between 0 and 5 minutes are most common. And so that's our modal class. Well, that's not right. Anyway, that should say 0 to 5. So ignore this, cross that out. It should be this one here, the first one here. That's our mode. Okay, the class containing the median. Median, we find n plus 1 divided by 2. Here we have 30 pieces of data, 30 phone calls. 30 plus 1 divided by 2. It's 31 by 2. Position 15.5. Here again, we're going to go through the table in order. Here we have 10 pieces of data. Here we have 7 pieces of data. So by the end of 10, we're already at 17 positions into our data. but we're looking for 15.5, so it must have occurred somewhere in here. So it's in that class 5 to 10. So